Hello, Dr. Mm. Oh! Hi! Sorry, I forgot that, you see my phone, I had it, like, set 5 minutes past. I thought that, sorry. Anyway, yeah, no, you're on time. It's my bad. My bad. Go ahead and sit down. But yeah, that's fine. We should probably wait till other people get here to start. But yes, I'm so glad that you are here. What's your name? Nice to meet you, Michael. Well, I take it from the fact that you're here on time that you are, if not a genealogy major, you're at least interested in the field. Well, really, that's awesome. I commend you for that. Right. So yes, earthquakes. Yeah. Okay, hi everyone. Come on in. Find a seat. There's no assigned seating in this class. You can sit wherever you want, and we're pretty chill here. My name is Dr. Amethyst Rose. You can call me Dr. Amy. Anyway, so a little bit of background on me. I am a mineralogist professionally, but I do also teach here at the university. I teach Intro to Earthquakes, which is this class, Intro to Volcanology, as well as Mineralogy. So, right, since we do them by semester, this semester this is earthquakes. If you're interested in mineralogy, we will be doing that course later on this year. All right, well, so, okay, hold on 1 second. Sorry, I just had to ground myself. Also, you know what? I always do this. I'm sorry. I'm going to take off these shoes. I know it's really unprofessional, but I'm not used to wearing heels. And oh, that is much better. Right. Anyway, so intro to earthquakes with Dr. Amethyst Rose, mineralogist. So you have probably heard of earthquakes before. Raise your hand if you have not. Haha. Yes. See, you all have, obviously. But what exactly is an earthquake? An earthquake can be defined as the sudden, violent shaking of the crust along fault lines that are moving under the surface, releasing energy in the form of seismic waves. That was a lot of vocabulary. Don't worry, we will get into explaining what all those things mean. For now, remember keywords such as fault lines and seismic waves. Seismic, anytime you hear the word seismic, it refers to earthquakes. That's what scientists who study earthquakes specifically are called seismologists. And the equipment that is used to measure earthquakes is called seismograph. So, right, yes. Basically anything, seismic waves, that is, seismic waves are, we'll get into that in a second. Earthquakes are classified based on how much energy they release. They can range from undetectable to incredibly violent and destructive. When I say undetectable, it would be like there are earthquakes that happen all the time, but people on the surface can't feel them because they're so minor. Really, up to like a magnitude 3 earthquake, you really won't feel. Now, of course, seismographs will pick this up, so it is detectable, but it's undetectable by like the regular human sense. Sort of like how microscopic organisms exist, but you cannot see them without a microscope, right? Okay. So, right, they can range from undetectable to very violent and destructive. There have been quite a few large earthquakes lately. It is a bit of a concerning trend. If you have heard about that, there have been quite a few large quakes which is part of why it's so important to study them, just to make sure, you're prepared. I mean, here we are in Alabama. There aren't earthquakes very often. However, as we'll come to learn, it is possible to have an earthquake here. All right. So there are three different types of seismic waves that can be emitted by earthquakes. Well, not can be, that they do emit. Three basic types. There's P waves, S waves, and surface waves. Primary, secondary, and surface. Now the surface waves are the most destructive. They cause the earth to wobble like this. Primary waves travel, they are the fastest, and secondary waves are a little bit slower. There's also like further types. There's Rayleigh waves and love waves, but these are the three basic types. Right. So I'm going to come show you this diagram. This is let's see. So this is a crudely drawn drawing of the Earth's surface, plate boundary, and this is meant to be underground. This is the surface. So when an earthquake strikes, it will happen within the crust. The area where it strikes is called the hypocenter. Now the epicenter is the area that is directly above the earthquake on the surface. So the epicenter would be the area of land that is affected above the surface. So, right, and the closer you are to the epicenter, obviously the shaking is going to be stronger. So we measure earthquakes by magnitude. What is that? On the moment magnitude scale. Then we also measure them by intensity. Intensity refers to the measure of shaking and damage on the surface. So the intensity will vary depending on, how close you are to the epicenter. The closer you are, of course, the intensity is worse. But the magnitude of the earthquake is just that. It's, say, 6.5. It's 6.5, but the closer you are to the epicenter, the stronger it'll feel. Does that make sense? Great. You guys are so smart. All right. So, by the way, it used to be called the Richter scale, but it is now the modified magnitude scale. Right. But it still kind of refers to the same thing. So here, the modified Mercalli intensity scale lists intensity from 1 to 10 of earthquakes. So 1 is, like we were talking about, the undetectable earthquakes that are not felt whatsoever. Then a 2 and a 3 would be considered weak. You might notice a little bit of shaking, but possibly not. Now 4 is light, 5 is moderate, as you can see it goes up. About, if it's anything above a 4, you would probably feel it. 6 is strong, 7 is very strong, 8 is severe, 9 is violent. I mean, they're all violent, but violent is what it's called. And 10 is extreme. Right, I don't think there have been any 10 magnitude earthquakes in recorded history. That doesn't mean that they didn't happen, it's just they didn't know about that. But the highest, there have been earthquakes at 9.0 and above. Those are really destructive. But oftentimes they do occur in more isolated areas, such as Kamchatka, Russia, which ruptured, it ruptured last year, if you remember, when the Kamchatka earthquake generated a large tsunami that actually hit Hawaii. And the tsunami wasn't that devastating, but it did generate um, this earthquake all the way over in Russia on the other side of the world. It sent waves, displaced the seafloor, which I'm getting ahead of myself. Tsunamis, we're going to talk about more in the lecture. But right, earthquakes do cause tsunamis, I'm sure you knew that. But how do they and why do they, we will get into later. Okay. Oftentimes, if there's an earthquake, there will be aftershocks. They're very common. They're usually less than the original earthquake, but they could be more, or and they don't have to be aftershocks, but there could be. And then a foreshock would be a small earthquake that happens before a major earthquake. And people like, oh, there was that little earthquake the other day. Oh yeah, that was a foreshock. We should have known. Well, anyway, no offense to anyone. Right, and here we go again. Earthquakes can be catalysts for tsunamis, which we were just speaking about. If an earthquake occurs on the seafloor, it could generate a tsunami. Tsunamis are generated when there are earthquakes under the oceanic crust and above magnitude 6.5, quakes are likely to generate tsunamis. Below 6.5 is not necessarily, I mean, it could produce tsunamis, but also doesn't necessarily have to. And if they were to produce a tsunami, it would be smaller. Now, a 6.5 earthquake, it can be quite destructive, but it's not as destructive as it could be. Anyway, so basically, tsunamis happen because the crust literally gets displaced, and it displaces this large amount of water. So, all that water, basically, the seafloor rises. You could think of that. So, the water level doesn't change, it rises up because the seafloor went up. Does that make sense? So that's why the waves are like that. Does that make sense? Good, good. Not everyone gets that. How to stay safe in an earthquake. That is an important. Does anyone know what you should do in an earthquake if you were in one? Like if an earthquake were to strike right now and it was, above a 3 on the scale, what would you do? Yes. Very good, Michael. Get under shelter, like for example that table back there or one of your desks, and cover your head as much as possible. Cover your face, protect your eyes, but cover your head as much as possible because obviously that is the most vulnerable part of the human body. We don't really have earthquake drills here. That's because they don't really happen. But I do remember in California, where I used to live, they would do earthquake drills very often. It was quite stressful. I'm sure you all know what a fire drill is like. Think about that, except an earthquake, and that's a little bit more, I don't know. It depends. Thankfully, we don't have to do those here. Here's a list of some of the largest earthquakes in recorded history and their magnitude. In 1964, there was a 9.2 earthquake in Alaska. In 2004, there was a 9.1 earthquake in Sumatra, Indonesia. In 2011, there was a 9.1 in Tohoku, Japan, 9.0 in Kamchatka, Russia, the place I was just talking about. This was back in 1952, 9.0. And the quake that struck last year in Kamchatka, I believe, was close to that. It was not quite 9.0, I think it was 8.6, but that's still really high. The good thing about Kamchatka is it's really remote. There aren't a lot of people there. It's actually a fascinating place, full of volcanoes and seismic activity, and honestly very beautiful, but it is a wild location. And in 1906, there was an 8.8 magnitude earthquake in Esmeraldas, Ecuador. Of course, this is a very short overview of earthquakes. There are hundreds of earthquakes every day, if not thousands. But these are some of the ones that are most destructive. Why are some quakes more likely to occur in certain locales than others? So why are earthquakes more likely to happen, say, in California than here in Alabama? Does anyone know? Yes, that's correct. Because we don't really have fault lines over here. And California is situated along a very large fault line. It's part of the Pacific Ring of Fire, which goes all the way around the Pacific Ocean from the tip of New Zealand all the way to the tip of Chile, and it is the most seismically active place on the Earth, zone of the Earth. It is a very large zone, but that zone produces over 90% of the world's earthquakes, and California is situated right smack there, which I really do have to say that it is silly that people live there. I know, I'm guilty of living there myself, but at least I moved, right? Anyway, so fault lines. Fault lines are boundaries in the crust basically, the crust is not one solid piece, right? So the crust has boundaries. Like lines. You have like a block and a block and a block. And the dividing line between the blocks is called fault lines. And so what will happen is sometimes the crystal pieces will be moving against each other. There are different types of faults. There's reverse faults. There's strike slip faults. We're not talking about this today necessarily, but if you're interested in plate tectonics, we can discuss that more. But all right, so when plates move against each other, they can generate earthquakes, and because of the intense displacement. Like imagine it takes a lot of energy for that rock to move, and so the energy from rocks moving against each other is what produces the earthquakes. The Earth is governed by plate tectonics. We're going to cover that a little. The crust is not a solid chunk of rock. It contains fractures below the surface creating plates. So the different pieces of the Earth's crust that are kind of put together like a puzzle piece, you can think of. They fit together, and the different pieces of the puzzle are called plates. So depending on, some plates are really large, like the Pacific plate. Some plates are smaller, like the Cocos plate, but they're all valid crustal plates, and I love them all. Quakes are more likely to occur along fault lines, but they can happen anywhere. There are so-called intraplate seismic zones, and these are areas, for example, the New Madrid seismic zone, which is